Good morning, CSEC students. Welcome to another live class. This morning we're going to be looking at algebraic fractions, and we're going to multiply and divide. So the last session that we did on algebraic fractions, we were actually adding and subtracting algebraic fractions. So this morning we're going to look at the multiplication and division. All right, so it's the same principle, just as with the addition and subtraction of algebraic fractions, the same principle that applied to adding and subtracting regular fractions. Likewise, when we're multiplying and dividing algebraic fractions, we follow the same principles as when we're multiplying and dividing regular fractions, which means we are going to see which terms in the numerator can cancel which term in the denominator. And then, so it has to be top to bottom. And then now we see, when we're done canceling and there's nothing more to cancel, we multiply the numerators, multiply the denominators, and then again we look to see if we can cancel the answer, the final answer. So let's just work a few of those problems. All right, so let's say we have all right, so let's say 4x over 5y times 10x squared y squared over 8x. All right. So this is the fraction that we're given. So we're going to see, first of all, so remember, when you're multiplying fractions, you first check to see what can cancel what. Okay. So, and we can't cancel sideways. So you can use this x and cancel that x. You can use this one and cancel this one. Or this one and cancel that one. Because remember, laterally we're multiplying, but vertically we're dividing. So you can cancel vertically or diagonally. So this x can cancel that one. You can put a 1 if you want, x into x1, x into x1, but you really don't have to in this case. X cancels x, right? And the 4 can go into the 8, so 4 into 4, 1 time, 4 into 8, 2 times. 5 can go into 10, 5 into 5, 1, 5 into 10, 2. And the 2 cancels this 2 cancels that one. And what's left? The y. So this y will cancel one of this y. So what we can do is y cancels itself, and we can just cross out the square to show that we're left with 1y there. All right. So this y to the first power cancels y square, leave back y up here. So the final answer then we have what? We have at the top, all we have is x squared and nothing left at the bottom. So the answer is x squared. The answer is x squared. All right, so suppose we had 6wx over 21y to the fourth power times 14y to the third power over 4w squared and x to the sixth power. All right, so that's what we have. So look at that carefully. Look at it carefully. And tell yourself, what would you do? What are you to do here? So we have 6wx over 21y to the fourth power times 14y to the third power over 4w squared x to the sixth power. So let's see what can cancel. So let's use a different color just to let's use the yellow. So 7 can go into 14 and 21. So 7 into 14, 2. 7 into 21, 3. 3 can go into 6. 3 into 3, 1. 3 into 6, 2. 2 can go into 4. So either this 2 or this 2 we can use. 2 into 2, 1. 2 into 4, 2. And then this 2 cancels that one. All right. In terms of the letters now, the variables can go into y to the fourth power and 1y is left. So that's the y we have here. So the 3 cancel the 4 and leave 1y. W cancels the w square, leave w. And x cancels x to the sixth power and leave x to the fifth power. So the final answer at the top, we just have 1 because all the variables got cancelled and the numbers. So we just have 1 at the top. At the bottom, we have y, we have w, and we have x to the fifth power. So let's put them in alphabetical order. So w, x to the fifth power, and y. So that's our answer. 1 over w, x to the fifth power, y. So tell me if you have any questions regarding that one. Okay, so do you understand what took place with that one? If you get it, just say, Miss, I got it. Miss, I understand. Miss, I got it. If you don't, let me know where you're not getting, which part of it you want me to go over. Which part, can you identify which part of it you're not getting? So let's do another one. So remember, it's the same principle as when you're multiplying and dividing regular fractions. All right, so let's say, give me 1 second. one part later, you can work it again. It's dry now. The one that was done last time is drying. All right, so let's do another one. So let's say we have 20 x to the third, y to the fourth over 35 p q times 21 p to the third power q to the seventh power over 16 x and y to the eighth power. So let's see what we're left with. So we're looking top to bottom or diagonally what we can cancel. So we can start by canceling the coefficients first, the numbers. So let's see, we can use 4 to cancel the 20 and the 16. 4 into 16 goes 4. 4 into 20 goes 5 times. 7 can go into 21 and 35. 7 into 21, 3 times. 7 into 35, 5 times. And this 5 can cancel that one. Okay. In terms of the variables now, the letters. So this is x to the first power. So we can cancel that and cross out the 3 and put 2. So x cubed divided by x leaves x squared. Y to the fourth power goes into y to the eighth power and leave 4. So if we have 8 y's and we have 4 y's, 4 of them cancel out, leave back 4. So it's not that we're dividing 8 by 4. It's 8 y's and we cancel out 4 of them, so 4 y's are left. For the p's and q, p can go into p cubed and leave back p squared. And q can go into q to the 7th power and leave q to the 6th power. All right, so what we have left, no coefficients at the top. We have an x squared, we have a p squared. Oh, we do have a coefficient at the top. So we have 3. So we have 3 x squared, p squared, q to the 6th power over, nothing left over here. We have 4 y to the 4th power. All right, let's do one more multiplication and then we go on to the division. All right, so let's say we have 7a, b, c over 9 x y times 15 x y to the 3rd power over 42 a to the 4th b. So let's look at these and see what can be cancelled. In terms of the coefficients, so 7 can go into 42. can go into 42 6 times. We can use 3 to cancel the 6 and the 15, or the 9 and the 15. So 3 into 6, 2. 3 into 15, 5. In terms of the variables, this a can cancel one a out of the a to the 4th power, so we're left with a to the 3rd power. That b cancels that b. There's no c down here. This x cancels this x. This y cancels one y out of the y cubed and leave back y squared. So what we're left with, at the top we have a 5, we have a c squared, and we have a y squared. At the bottom we have 9 times 2, which is 18, and we have a to the 3rd power. All right, so that's it for the addition. So before I go on to the division, the multiplication, that's it for the multiplication. Before I go on to the division, let me know if you have any questions. Any questions for the division? What is the question? All right. So let's go on to the division then. So if we have 14, a to the 5th, b cubed over y cubed divided by 8 x squared a over 42 y to the 4th. So what we need to remember for division is that, remember, when we're dividing fractions, what we're supposed to do? We're supposed to rewrite the first fraction, change the division to multiplication, and invert the second fraction. Remember, that's what we do when we divide in fractions. So we're to write back the first fraction. So we write back the 14 a to the 5th b cubed over y cubed, change the division to multiplication, invert this fraction. So we're going to have 42 y to the 4th over 8x squared a. And now we're going to see if we can cancel. All right, so looking at this now, let's see. So we can use 2 to cancel these 2 or these 2. So 2 into 8, 4. 2 into 42, 21. 2 into 4, 2. 2 into 14, 7. Y to the third power cancels y to the fourth power and leave y to the first power, or just y. We don't have any x squared up here to cancel, but a cancels a to the fifth power and leave a to the fourth power. All right, so our final answer then is at the top we have 21. We have, oh sorry, there was a 7 here. So I need to multiply that 21 by 7. All right, so 7 times 21, that's 147. And we have a to the fourth power. We have b to the third power. We have y. And at the bottom, we have 2. So we have a 2 and x squared. So 2x squared. Again, so let's say we have x over 23 c d to the fourth power divided by 27x squared y fifth power divided by 46 c to the third power d and x. So we're dividing fractions, so we need to rewrite the first fraction. So just write it back, 23 c d to the fourth. We need to change the division to multiplication, and we need to invert the second fraction. So what's at the bottom will come to the top. So we're going to have the 46 c to the third d x over 27 x squared y to the fifth. And now we're going to cancel. So 23 goes into 46 2 times. C goes into c to the third power and leaves c squared. D goes into d to the fourth power and leave d to the third power. X cancels x squared, leave x, and then this x cancels that one. All right, so at the top, we have nothing up here, just 1. We have a 2. We have a c squared. So at the top, we have 2c squared. And at the bottom, we have a d to the third power. So we have 27. We have d to the third power. And we have y to the fifth power. All right, so look at that one. We're going to do 2 more division. 2 more division. So, but look at that and see if you understand it. We're saying that they were. Okay, so Lejeune Day says, I'm getting it a little. Ngozi says, understand a little better. So that's good. So hopefully by the time we do those next two, you both will be good to go. All right, so 2 more division. Let us use fractions now, right? So 3x y to the third 4 y divided 5 x to the fourth y to the sixth. All right, so these will be over q. That's over 7 p squared. And this is over, let's put a square here. This is over 5q All right, so that's what we're working. We have a multiplication and a division. We know that we're supposed to rewrite once it involves the division. So this part is fine. These two fractions are fine. They're multiplying. We're going to write them as is. So 3x y cubed 5q 4y 7. The division one now, we need to change the division to multiplication, invert this fraction. So at the top, we're going to have p q squared, and at the bottom, we're going to have 5 x to the fourth power y to the sixth power. All right, so now it's time to cancel. So let's see. Actually, none of the coefficients can cancel. 3 can't go into 5 or 7. 4 can't go into 5 or 7. All right, so we have to leave the coefficients alone for now. In terms of the variables, so this q cancels one of that q, leave back q. The p cancels the p squared, leave back 1p. This x cancels one of the x to the fourth power and leave x cubed. And y to the third power cancels y to the sixth power and leave 3. All right, so, and this y now can also cancel one of that one. So we actually have 2. We have y squared. So is that it? Everything cancels? I think so. All right, so 3 4s 12. We have q, so 12q. That's what's in the numerator. In the denominator, 5 5s 25 times 7, I believe that's what, 175. Let me double check that. So 25 times 7, 175. So we have 175 down the numerator side. For the variables, we have a p. We have a p and we have a x cubed and a y squared. So p x cubed y squared. And that's it. So we have one more to go. One more to go. And of course, I'm going to give you some to try on your own. All right, so let's say we have 121 g to the third power, h to the fifth power, All right, so we know that for the division, we need to rewrite. So we rewrite the first fraction. Change the division to multiplication. And we're going this fraction. So we're going to have 16 x to the fourth, y to the sixth. What's in the numerator is now in the denominator. G h to the 9. And we're going to see now what's cancel what at the bottom. Top to bottom or diagonal, right? So 11 into 121 goes 11 times. So g to the third, so this g cancels g to the third and leave g squared. That cancels y to the sixth. H to the fifth cancels h to the ninth power and leave h to the fourth power. And the x squared cancels x to the in the numerator, we have g squared. We have x squared. And we have y to the fifth. And in the denominator, we have h to the fourth power. And that's it. All right, so that's it. All right, so hopefully you get it now, and if not, just rewatch the video, practice, practice, practice. Just remember, it's the same principle that applies to multiplying regular fractions and dividing regular fractions. In the case of the multiplying, you simply have to see what terms in the numerator cancel what terms in the denominator. And when you've done that, you multiply the numerators, multiply the denominators. In the final answer, you see if anything more can cancel. For the division, write back the first fraction, change the division to multiplication, and invert the second fraction. And then you do similar steps as with multiplication. You cancel, and then you multiply the numerator, multiply the denominator, and see if the final fraction can be cancelled. All right, so that's it for multiplying and adding algebraic fractions.